Okay, so now if you're paying attention, you'll see that we've just put the last two together, right? The first two times ago, we did this first part. One time ago, we did this second part here, right? If you remember, both of those were negative acceleration. So this whole thing is somehow going to be negative acceleration because this is just the previous two graphs put together. Okay, so let's think about this, right? We start off, let's analyze, we don't have to analyze it from 0 to 5 and 5 to 10, but let's do that because I think sometimes that helps, right? So from 0 to 5 seconds, let's go from here to here, okay? In this region here. We start off with a positive velocity, right? This is a steep positive line here, and we go to 0. So we are moving in the positive direction, and we slow to a stop. Well, how do you do that? How do you slow to a stop? Well, we have a positive velocity. The only way to slow down is to have the acceleration in the opposite direction, okay? So from 0 to 5, it's negative acceleration, which, by the way, we can tell also because it's concave downward, right? We get to the concavity from below, okay? Now here, from 5 to 10, we can say, gee, we start at rest. That just means the velocity is 0, right? And we go faster and faster in the negative direction. Faster and faster. Because it's getting steeper and steeper in the negative direction. Okay? The only way to go faster and faster in the negative direction, if you have a negative velocity, right? And which you do after 5 seconds, right? Is to have the acceleration in the same direction. Okay, so we know that since we're moving in the negative direction and we're going faster and faster, it must be a negative acceleration. Okay, it's also, by the way, concave from the downside, from below, right? So this is negative acceleration due to its concavity. In fact, this whole thing from 0 to 10 seconds is downwardly concave. Downwardly. Downwardly concave. There we go, right? 0 to 10 seconds, the whole thing is downwardly concave. This whole thing, right? All of this, and there's no inflection point here. It doesn't change the direction of its concavity, okay? Yeah. All right, let's take a look at this guy. There we go. All right, so let's take a look at the slider here. Let's start on the left side there. So we've got a velocity of 3.6. Notice that as time goes down along, that gets less and less and less and less and less and less. It's decreasing. In 5 seconds, it went from 3.6 to 0, right? Let's just do a quick calculation here. 3.6 to 0 in 5 seconds, right? So it's negative 3.6 divided by 5, right? That is negative 0.72 for this first part here, right? Now let's look at the last part here. Notice we have 0 and we go to negative 3.6, right? Well, again, negative 3.6 divided by 5 is 0.72. The acceleration the whole time for this whole thing, the acceleration for this entire thing is negative 0.72 meters per second, okay? So notice that we go from positive velocity to 0 to the same negative velocity, right? Remember this, right? Remember this, because if let's say you throw a rock straight up, and let's imagine we can neglect air friction, right? If you throw a rock straight up at, say, well, I don't know, 3.6 meters per second, it's going to go up into the air for some amount of time, right? It's going to stop instantaneously and come back down. It'll be going the same speed when it hits your hand. This is a position time graph of you throwing a rock in the air. It goes up, it comes down, okay? The entire time, the acceleration is exactly the same. It's one of the coolest things. All right, I'm done with this.